Welcome back, reinforcement learning subject. The last session we completed first unit. In first unit we discussed about introduction of the reinforcement learning, framework, the key elements of the reinforcement learning framework like agent, environment, action, reward, states. Okay, next applications of reinforcement learning, deep reinforcement learning, applications of deep reinforcement learning, and string diagrams. Why we are using string diagrams in reinforcement learning? Describe the task or data flow process, explanation for the data, description of the data flow in reinforcement learning framework. We are using string diagrams. And multi-arm bundled problem, how to solve the multi-arm bundled problem, use how to balance the exploration and exploitation using epsilon grid approach, softmax selection process, and how to what is the difference between numpy and pytorch, and what are the features of the PyTorch, how to implement the reinforcement learning task in PyTorch, and how to implement the reinforcement learning task using neural networks. These topics and context bounded problem, solution for the context bounded problem, these topics we covered in first unit. The second unit is started with the multi-arm multi-arm bounded problem continuation with the Markov property. The second unit first topic is the Markov property. The Markov property in contextual bounded problem, the state describe the description of the state. It gives the more information with the context. It gives the state information with the context. Okay, that is the give the more information about the state. So the context bounded problem, we are consider the present situation of the state, only current situation of the state, which based on the current situation of the state, which we are select the action, optimized action to get the best reward. Okay, in that case we are select the we are choosing, we are consider only current situation of the state. Okay, the based on the current situation of the state, we take that optimized action, we take the optimized action to get the best reward. That situation is called a Markov property. That process is called a Markov property. That is the Markov. That Markov property is a very important in reinforcement learning. That is called a Markov decision process. A game or any control task that exhibit the Markov property. Markov property means it considers the only current state situation is said to be a Markov decision process. In Markov decision process, the current state alone contains enough information to choose optimal action to maximize future rewards. The Markov decision process, we are take the only current state alone. We are taking only current state to take the to choose the optimal action to maximize the future rewards. Okay, modeling the control task as an MDP. MDP means Markov decision process is the key concept in reinforcement learning. The MDP models we are consider only current situation, so it is not required to store the previous history or previous data. So it not require the previous data, so it will not require any additional memory. Like a card game, the blackjack, this is known as the 21 in card games, is an MDP, Markov decision process, because we can play the game successfully just by knowing our current situation, current state. So any action we are taking based on the current state information, that is called a Markov decision process. Okay, the Markov property, we are analyze the what are the tasks satisfy the what are the tasks are related to the Markov property. We are taking some task, driving a car, deciding whether to invest in a stock or not, choosing a medical treatment for a patient, diagnosis of the patient illness, predicting the which team will win in a football game, choosing the shortest route to some distance, aiming a gun to shoot a distant target. Okay, these are tasks what are the satisfy the Markov property, what are not related to the Markov property. The first one is driving a car. Okay, driving a car is a it is generally we are considered the driving a car current situation of the surroundings only. Here the road is empty. Here we are taking based on this current situation. Here the driving controlling task are taking here the some traffic is there based on the current situation. Okay, here the traffic is free traffic. So we are the car driving is considered the only current state information. It depend on current state information to take the actions. So the driving a car is the satisfy the Markov property. The second one is deciding whether to invest a stock or not. It does not meet the Markov property. It does not meet the criteria of the Markov property. We are consider the previous history of this trading, previous stock, any company stock purchasing. We are consider the previous history of the company. So it is not, we are not taking decision on current depend on current state. So we are consider the previous history also. So it is not related to the criteria of the Markov property. To invest a stock in a stock or not does not meet the criteria of the Markov property. The next one is choosing a medical treatment. The treatment we are give the treatment on present situation, present illness of the patient only. So it is also meet the Markov property. Choosing a medical treatment seems to have the Markov property because you don't need to know the biography of person to choose a good treatment for what ail them right now. So it is we are giving the treatment based on current sickness of the patient. Next one is diagnosis. Diagnosis is not like a treatment. Where diagnosis is we are consider the previous history also, previous history of the patient. In contrast, diagnosis would definitely require the knowledge of past states of the patient. So it is not meet the Markov property. Next one is predicting which football team will win does not or which cricket team will win the match. It is also we are considered the past history or past matches history we are required to take the decision that team will win or not. So it is not it's not depend on current situation. Next one is choose, so it is not a Markov property. Next one is choosing the shortest route. It is belong to the Markov property because you just need to know the distance to the destination for various route, which does not depend on what happened in yesterday or day before yesterday. So we are depend on current position only. Next, aiming a gun to shoot. It is also reach the target Markov property. So these all are the we have the clear understanding what is the Markov property, what are the tasks are related to the Markov property, which task we are applied the Markov property. Markov property means Markov decision process means which follows the Markov property. The Markov property is take that decision or actions based on the current information of the state or current situation of the state only. Now one example. In this example, we have the three states: crying a baby, smiling a baby, and sleeping baby. Okay, three states are there. Each state has the rewards. Okay, -1 for the crying baby, smiling baby is the +2, sleeping baby is +1. Here also mention the actions. What are the actions here? Feed and don't feed. These two are the actions here, and the probabilities of the next state probabilities also mentioned here. Crying, don't feed. If they are taking don't feed action, we apply the don't feed action. But again, the probability of again crying is 0.95. If it is don't feed, the 0.05% probability is sleeping baby. If the crying baby feed, the 0.2 probability is smiling baby state. It moved to the smiling baby state. The crying baby feed 0.6%. The state moved to the sleeping baby. And okay, this is the here crying baby is a current situation. Based on the current situation, we are taking any two actions. Which one is the best action? Here 0.6 is the sleeping state. In the sleeping state, we got the +1 reward. If you are feeding, we get the either 0.2%, we are go to the smiling baby state. If you are go to the smiling baby state, we got the +2 reward. Okay, it is a Markov property, the simple example, the crying baby situation, we are apply the feed, we are getting either smiling baby or sleeping baby. The most probability is sleeping baby. So we got the +1 probability. If it is going to smiling baby, you got the +2 rewards. Okay, this is the Markov property. The Markov property is the one of the important concept in reinforcement learning. We are applying the to solve some of the tasks, some of the problems based on the current state information. Based on the current state information, we are select the optimized reaction to get the best reward in future. Thank you.